The world of AI is in a strange and exciting time. With transfer learning, it's never been easier to deploy a fully trained artificial intelligence model and start using it for real world problems. The idea here is to use pre trained models already that are out there available on the internet for anyone to use. And for a lot of common problems, you can just import a pre trained model that somebody else did all the hard work of putting together and optimizing and figuring out the right parameters and the right topology and just use them. So, for example, if you're trying to do image classification, there are pre trained models out there that you can just import. Some of them are called ResNet, Inception, MobileNet, and Oxford VGG are some examples, and they come pre trained with a very wide variety of object types. So, in many cases, you can just unleash one of these off the shelf models, point a camera at something, and it will tell you what it is. That's kind of freaky. Similarly, for natural language processing, there are pre-trained models available as well, such as Word2Vec and Glove, that you can use to basically teach your computer how to read with just a few lines of code. Now, you can just use them as is, but you can also just use them as a starting point if you want to extend on them or build on them for more specific problems. So even if they don't solve the specific problem you're trying to solve, you can still use these pre-trained models as a starting point to build off of. That is, a lot easier to get going with. You don't have to waste a lot of time trying to figure out the right topology and parameters for a specific kind of problem. You can start with a model that's already figured all that out for you and just add on top of it. This is called transfer learning. Basically, we're transferring an existing trained model from somebody else to your application. Now, you can find more of these pre-trained models in what are called model zoos. A popular one is called the Cafe Model Zoo, and it's I'm not sure what to think of all this. I mean, it is super, super easy to deploy AI now, as you'll soon see in our next example. You can just import an existing Model Zoo model and start using it with just, 4 or 5 lines of code. You don't have to really be a very good developer anymore to actually use AI for practical applications. So kind of a weird place for the industry to be right now, and kind of opens up a lot of interesting and potentially scary possibilities of how people might start to use this technology when there's such a low barrier to entry now of actually using it. Anyway, let's dive into a real world example and I'll show you just how scary easy it is now. So let's dive into transfer learning. Open up the transfer learning notebook in your course materials and you should see this, and you will soon see just how crazy easy it is to use and how crazy good it can be. So we're going to be using the ResNet 50 model here. This is used for image classification. So it's an incredibly easy way to identify objects in arbitrary images. So if you have a picture of anything, maybe it's coming from a camera or video frames or what have you, this can tell you what's in that picture pretty reliably, it turns out. So let's have some fun with it. So just to prove a point, I'm going to try some of my own vacation photos here with it. So we're going to be sure that the pictures that I'm giving ResNet 50 to classify are pictures that it's never seen before, and see what it can do with it. For example, I took this picture of a fighter jet while I was exploring the deserts of California. Let's just run that. This is included with your course materials. And there we have a picture of a fighter jet. So as a start, let's see if the ResNet 50 model can identify it and see what's involved in actually coding that up. First, we just need to import the modules we need. So we need to import the ResNet 50 model itself. Again, that is built into Keras along with several other models as well. We don't even have to go to the trouble of downloading and installing it. It's just there. And we're also going to import some image pre-processing tools, both from Keras itself and as part of the ResNet 50 package itself. We're also going to import NumPy because we're going to use NumPy to actually manipulate the image data into a NumPy array, which is ultimately what we need to feed into a neural network. So let's go ahead and run that block. Now, one sort of limitation of the ResNet 50 model is that your input images have to be 224 by 224 resolution. That's in part to make sure that it can run efficiently. It's also limited to one of 1,000 possible categories, and that might not sound like a lot, but I think you'll be surprised at just how much detail it will give you as to what a thing is. So let's go ahead and load up that image again. This time we will scale it down to 224 by 224 while we're loading it. And we will convert that to a NumPy array with these 2 lines of code, and then call the ResNet 50 model's preprocess input to do something to prepare that data. I assume it's scaling it down into whatever range it wants and maybe doing some pre-processing of the image itself to make it work better. It's kind of a black box, and that's a little bit what's weird about using transfer learning. You're just sort of taking it on faith that it's doing the right thing, but from a practical standpoint, that's not a bad thing to do. Let's go ahead and run this. All right, so it's pre-processed my image. That was pretty quick. Now we'll load up the actual model itself. One line of code is all it takes. Model equals ResNet 50. The weights there represent that it's going to use weights learned from the ImageNet data set. So you can even use variations of ResNet 50 that were trained on different sets of images there potentially. So let's go ahead and load up the model. And that's done. So now we can just use it. So we now have a pre-trained image classification model here with one line of code, and we can just use it now. All we have to do is call predict on it, and we're done. That's it. It's really that easy. So let's try it. We have, as you recall, our pre-processed fighter jet image here in the X array here, and we will just call model.predictX and see what it comes back with. I'll come back with a classification, and to translate that into something human readable, we'll just call the decode predictions function that comes with the ResNet 50 model as well. It's just that easy. Okay, literally 2 lines of code here, right? We just had 1 line to actually load up the ResNet 50 model and transfer that learning to our application, if you will, specifying a given set of weights that was pre-learned from a given set of images. And then we just call predict on that model, and we're done. That's it. Let's run that and see if it actually works. Wow. Okay, so yeah, its top prediction was actually warplane, and that's exactly what this is a picture of, even though it's never seen this picture before, ever. And I didn't do anything to make sure that the photo was like from the right angle or properly framed or anything like that, or, you know, pre-processed with a lot of contrast. It just works. It's kind of spooky good. Its second guess was a missile followed by a projectile, and yeah, there were missiles and projectiles on that plane as well, so not only did it tell me it was a warplane, it told me that it was a warplane that had missiles on it. I mean, wow. That's crazy good, right? Let's try it with some other images. Maybe we just got lucky. So let's make a little convenient function here to do this on a given image more quickly. So we'll write a little classify function here, and it will start off by displaying a picture of the thing that we're starting to classify here. It will then load that image up, scaling it down to the required 224 by 224 dimension, convert that to a NumPy array, pre-process it, and then just call predict on the ResNet 50 model and see what it comes back with. So now we can just say classify and whatever our image file name is, and it will tell us what it is. So we've reduced our little bit of code here to just 1 line now. So I can now just hit Shift-Enter to define that function, and now I can just say, well, I have a file called bunny.jpg in my course materials. Let's classify that. Shift-Enter. There's a picture of a bunny rabbit in my front yard that I took once. And sure enough, the top classification is wood rabbit, followed by hare. So not only is it saying it's a rabbit, it's telling me what kind of rabbit. I don't really know my rabbit species that well, so I'm not sure if that's actually a wood rabbit, but it could be. I don't know. Either way, it's pretty impressive. I mean, it's not even like a prominent piece of this image. It's just sort of like sitting there in the middle of my lawn, and it's not even that clear of a photo either. Imagine this scaled down to 224 by 224. There's really not going to be a lot of information there, but it's still figured out that that's a rabbit. How about a fire truck? Picture of a fire truck. And this isn't a normal fire truck either. This is like at that same aviation museum that I took a picture of that warplane of. It's a sort of an antique fire truck that was used by the Air Force. But still, fire engine is the top prediction. Wow, that's kind of cool. I took a picture of my breakfast once at a fancy hotel in London. Let's see what it does with that. A full English breakfast, mind you. When in London, one must eat as Londoners do. Actually, I don't know if they really eat full English breakfast there, but it's still good. Yeah, so it picked up that there's a dining table in this picture. There's a tray containing my food. A restaurant. I mean, well, this was actually room service, but you could definitely imagine that's in a restaurant instead. So yeah, again, an impressive job here on a random photo from a vacation. Like, it's never seen this picture before. I took absolutely put no thought into making sure this was a picture that would work well with machine learning or artificial intelligence for image classification. Let's keep going. When I was in England, I visited some castles in Wales. It's a picture of a castle I visited. Go to Wales, guys. It's beautiful there. Yeah, it's a castle. That's its top prediction. Second guess was a monastery or a palace. Both good guesses, but yeah, it's a castle. And, you know, it's not even a typical looking castle, and it still figured it out. This is incredible stuff. All right, let's see if I can trip it up. I also took a trip to New Mexico once and visited what's called the Very Large Array. This is basically an array of giant radio astronomy dishes. with only 1,000 classifications, I wouldn't imagine it would get this, right? So there's the picture. It's just a bunch of giant radio astronomy telescopes. And it says it's a radio telescope. This is mind-blowing stuff, guys. All right, one more. I took a picture of a bridge once. I don't even remember what bridge it is. Oh, London Bridge, apparently. What's this, ResNet 50? A suspension bridge. And also there's a pier and a chain link fence in there as well for good measure. So that's pretty impressive, right? I mean, so if you need to do image classification, you don't even need to know the details of how convolutional neural networks work or how to tune them and how to like build up the right topology and iterate on the right hyperparameters. You can just use somebody else's work who already did that. And by using model zoos from the Cafe Model Zoo or elsewhere, for a lot of common problems, you can just get up and running in a couple of lines of code. It's never been easier to use artificial intelligence in a real-world application now. So although it's good to understand the fundamentals, especially if you're going to be doing something that nobody's ever done before, for common AI problems, there's been so much research in recent years that there's a good chance that somebody's already solved the problem that you're trying to solve, and you can just reuse their results if they were kind enough to publish them on a model zoo somewhere. Wow. Try it out on some photos of your own too. Why not? If you have some, just throw them in the course materials and call my classify function on it and see what it does with it. Just have some fun with it. And you can also try some different models too and see how they behave differently. ResNet 50 was actually the model that worked the best for my photos, but there are other models included with Keras, including Inception and MobileNet that you might want to try out. If you do want to play with them, you'll have to refer to the documentation here. There's a link to it here. You do need to know what image dimensions that it expects the input in, for example, or else it won't work at all. So, yeah, give it a try. And, man, it's mind-blowing stuff, guys. Just kind of like sit there and let it sink in that it's that easy to use AI right now.